Welcome back. This is the third lesson recording for IM1, October 16th, 2020. So now we're up to how do I see starting value and speed from graph. Okay, starting value is where the turtles are starting. It looks like the lane 2 blue turtle started at 0 and lane 3 turtle, the purple turtle, started at 0 and lane 1 turtle started at 6. So what does the starting value tell us? That's actually the Y-intercept, isn't it? Okay, so, and the speed is actually the slope. Speed is same as the slope. The starting value is the Y-intercept. And how do I compare speed from graph? Well, the slope is you can compare the slope. You can say which is the steeper the line. Okay, steeper the line, the faster the speed. That means for the purple turtle, when it moved 1 foot, or when x changed by 1, y changed by approximately 1 1/3. Okay, what about for blue? When x changed by 1, y changed by 3 here. Okay, as opposed to when for the red turtle, when x changed by 1, y changed by 1. So the speed for the red turtle is 1 feet per second. Speed for the blue turtle was 3 feet per second, and speed for the purple turtle was approximately 1 1/3 feet per seconds. And since 3 is the biggest, and since from the graph that is the steepest, that it was going the fastest. Okay, so you are going to continue with card number 7 now. What would be the equation for each of the turtle? So please pause the video and try that. Okay, I am going to assume that you had a chance to explore different numbers and come up with the way to figure out the equation, but we can just figure that out from the graph as well. So let's think about each of the turtle. Okay, so for the red turtle, where is he starting? What is the Y-intercept? The Y-intercept is 6. And what is slope? We said the slope is as x changes by 1, the y changes by 1, so it's 1/1. So the slope is rise over 1. Rise is 1 and run is 1, so that's just 1. So that means putting it together, the distance is, and instead of using y, I am using distance, is equal to, what is the slope? That's 1. And instead of using x, I am going to use t as my variable for time, plus what is b? It's 6. Okay, let's do for the blue turtle. Okay, that's lane 2 turtle. Where is he starting? He's starting at y-intercept of 0. Okay, what about slope? What is slope? As x changes by 1, y changes by 3. So it's rise over run. Slope is 3/1, which is 3. So the equation is distance is equal to 3t, because that's the slope, plus 0, because we don't have a y-intercept. Or we do have a y-intercept, we have a y-intercept of 0, so we're adding 0 to it. Okay, then finally let's do for the purple turtle. In the purple turtle, what is the y-intercept? Is 0 again. And what about the slope? Well, we don't want the approximate, so we want to figure out where I can pick. This would be a good point to use as the slope triangle. The run is 2, the rise is +3. So the slope is +3 divided by 2, which is really same as 1.5. the equation becomes distance is equal to 3 over 2 t plus, in this case there is no b value, so it's plus 0, or 3 over 2t. Okay, so why did we figure out the equation? Because when you have the equation, it allows us to calculate the distance d a turtle travels at any particular time t. Okay, so we don't have to just know when it reaches at the end. We can figure out how far was the purple turtle from the start line when time was 4. It's right here. Okay, or how far was the blue turtle when time was 4? He was over there. When time was 4, where was the red turtle? It was there. Okay, so the red started at 6 feet. So this one tells me the red turtle starts at 6 feet, travels 1 feet per second. So the equation is 6 plus 1t. And then blue is distance is 3t. And purple is 3 over t. 3 over 2 times t. Okay. So now you're going to do cut 8 of the decimals, and you're going to be creating your own race through graph. So think in terms of starting value and the speed when sketching, and then see if the turtle behaves the way you expect. So just kind of plan for a turtle to behave in a certain way, and then when you submit or when you're testing, you can tell, is it indeed behaving the way you expect it to. See if you can create a turtle that starts way behind the start line but still wins or races backwards, or the challenge will be to accelerate. That means pick up speed towards the end. Okay, I hope you had a chance to play around with that different equations and how the turtles would behave accordingly. Now let's get into turtle race new saga. We're going to try a different scenario. A turtle race is represented by d is equal to 2t plus 4. Okay, in this case, can you figure out where she is starting at? So is this the number, the 2, is that the number that's going to tell me the starting line? Or is it the 4 that's going to give me where it is starting at? Okay, remember 2 is the slope, 4 is the y-intercept. So this is the y-intercept, and this is the slope. Remember, slope is the one that gets multiplied to the variable, input variable. Okay, so what is her speed? So you need to tell me 2 things, and I'm asking you to do that in private chat. Okay, all right, so hopefully you had a chance. All right, so the speed is always going to be the slope, and y-intercept is going to be the starting point. So that means that this turtle is starting at 4 feet from the start, and it's moving at a speed of 2 feet per second. Okay, so it's starting at 4 feet and 2 feet per second. Okay, what about this one? Please tell me in private chat. If you have 20 minus 0.5 t, what is the turtle's start? Where is she starting at, and what is her speed? And where is she after 8 seconds? So I just want you to do the first 2 questions for now. Okay, where is she starting at? What is her speed? Okay, so I hope you had a chance to think about it. Now, if you are dealing with this, which is the y-intercept, which is the slope. Remember, the slope is always the number that is being multiplied to the variable. It's not the number that comes first or the second. You can't sort of see it that way because that could be reversed. But it's the number that is being multiplied to the variable input. And so it's 0.5, but it's not just 0.5, it's negative 0.5. So this is the y-intercept. I'm sorry, this is not the y-intercept, this is the slope. okay, because it's being multiplied to the variable. That's what I've been saying. Okay, and then what is this 20? The number that is being added, that's the y-intercept. And y-intercept is always the starting value. So it is going to be 20 feet. And what is her speed? It's 0.5 feet per second. But it's actually not just 0.5, but it's negative. What does negative 0.5 feet per second mean? The turtle's actually going backwards, isn't it? Okay, it's going backwards, starting from 20 feet, but it's going the opposite direction. It's moved, okay? And now finally, let's do the next question. Okay, where is she after 8 seconds? How can I figure out where she is after 8 seconds? I substitute 8 as the t. So that means, okay, let me clear everything. That means that after 8 seconds, I substitute for t to be 8. 0.5 times 8 is 4. So you're subtracting 20 minus 4, and that's 16 feet. So at 8 seconds, the turtle is 16 feet away from the starting line. That's what we have just figured out. Okay, so how about this? Answer in private chat. Turtle is racing at 5 feet for every 2 seconds and started at 3 feet ahead. What is her speed? Okay, when you're given this, what is her speed? So what do we know? We know 3 feet ahead. Is that the speed, or is that where it's starting? It's where it's starting. What is the speed? We know he's traveling 5 feet for every 2 seconds. So what is the speed? It's 5 over 2. What would be her the equation be? Okay, the equation speed is 5 over 2 and starting at 3 feet ahead. So y is equal to 5 over 2 t plus 3. Okay, so that's the end. So at this point, you are going to put a table of content in your notebook. And today we organize solving equations and distance, time, and speed linear equations. And I would like you to scan and submit picture of table of content from your notebook. So you should have been writing down the table of content from your notebook. Just take a quick picture and you submit it in Canvas. Okay, that's it. Take care.